Welcome to Astronomy Daily. I'm Anna, bringing you the latest astronomical wonders and space news from across the universe. Today, we have a stellar lineup of fascinating stories that showcase just how dynamic our universe truly is. We'll explore the surprising discovery of mini-moons lurking near Earth that might hint at a hidden population of lunar fragments in our neighborhood. Then, we'll look at a remarkable telescope that's literally shooting lasers into space to create artificial stars. I'll also share details about the James Webb Space Telescope's groundbreaking discovery of the coldest exoplanet ever found, and it's orbiting a dead star. Plus, get ready for the upcoming Eta Aquarid meteor shower, your chance to witness the cosmic debris from Halley's Comet lighting up our night skies. And finally, we'll update you on that Soviet Venus lander that's been stranded in Earth orbit for over 5 decades and is now making its way back home. So let's journey together through these cosmic tales that remind us just how wondrous our universe truly is. First up today, Earth's moon might be getting a bit of company in our cosmic neighborhood. Scientists have discovered what appears to be a second mini-moon, a small rocky body that travels near Earth's orbit. This new mini-moon, designated 2024 PT5, was first spotted last year by astronomers in South Africa, and the evidence suggests it may have been blown off our own moon during an ancient impact event. What makes 2024 PT5 particularly interesting is that it represents the second known lunar fragment traveling near Earth. The first, called Kamo-O'alewa, was traced to the moon in 2021. As planetary scientist Teddy Coretta from Lowell Observatory in Arizona puts it, if there were only one object, that would be interesting, but an outlier. If there's two, we're pretty confident that's a population. This discovery hints at a potentially hidden collection of lunar fragments orbiting in Earth-like paths around the sun. Think of it as Earth traveling in its highway lane around the sun, while these mini-moons cruise along in adjacent lanes, occasionally merging into Earth's path before moving on again. What's fascinating about 2024 PT5 is how researchers identified its lunar origin. After its discovery, scientists quickly turned the Lowell Discovery Telescope toward this space rock and studied it using both visible and near-infrared data. The composition matched rocks brought back by Apollo missions and the Soviet Union's Luna 24 mission, confirming its lunar heritage. Size-wise, 2024 PT5 is relatively small, estimated at just 26 to 39 feet in diameter. Scientists believe it was likely excavated when an asteroid or other object crashed into the moon, ejecting material that eventually found its way into an Earth-like orbit. Coretta aptly compared this discovery to finding a new kind of evidence at a crime scene. These lunar fragments offer scientists a unique opportunity to study the effects of massive impacts on the moon. By matching the debris to specific lunar craters, researchers may gain new insights into how cratering events shape planetary bodies throughout the solar system. The two confirmed mini-moons appear quite different from each other. Kamo-O'alewa is larger and shows signs of longer exposure to cosmic rays and solar radiation, suggesting it's been in space longer than 2024 PT5. Their orbits also differ slightly. While 2024 PT5 occasionally crosses Earth's orbital path, Kamo-O'alewa maintains a more consistent quasi-satellite orbit that keeps it in Earth's vicinity for several consecutive orbits. Researchers are now actively searching for more of these lunar refugees, with Coretta suggesting that some asteroids previously classified as unusual might actually be disguised lunar rocks. As new large-scale survey telescopes like the Vera Rubin Observatory come online, we may soon discover that Earth's mini-moon population is much larger than previously thought. Next up, a rather intriguing experiment. At the Paranal Observatory in Chile, astronomers have developed what might be the most dramatic solution to a persistent problem. They're shooting powerful lasers into space. But this isn't science fiction, it's cutting-edge astronomy at work. The UT4 telescope, one of 4 8-meter behemoths that make up the Very Large Telescope Array, is equipped with a remarkable system called the 4 Laser Guide Star Facility. This system allows the telescope to do something extraordinary: create artificial stars high in Earth's atmosphere. When we look up at the night sky, we see stars twinkling. While this might be beautiful, it's actually a serious problem for astronomers trying to capture clear images. That twinkling is caused by atmospheric turbulence. Essentially, we're looking at space through a constantly shifting layer of air that distorts the light. The UT4's solution? It fires four brilliant laser beams about 90 kilometers up into the atmosphere, where they excite sodium atoms, causing them to glow brightly. These glowing points effectively create guide stars that the telescope can use as reference points. By observing how these artificial stars are distorted by the Earth's atmosphere in real time, the telescope's adaptive optics system can precisely adjust the shape of its secondary mirror to counteract the blurring effects. It's like wearing glasses that constantly update their prescription to match changing conditions. The results are spectacular. This technology allows UT4 to capture images from the ground that are almost as sharp as those taken from space-based telescopes, but at a fraction of the cost, and with the ability to upgrade and maintain the equipment regularly. The success of this system has been so impressive that plans are underway to equip the other three telescopes in the VLT array with similar laser technology. This is part of a series of upgrades to the VLT interferometer and its Gravity Plus instrument, which can combine light from multiple telescopes to create what is essentially a huge virtual telescope. Not far from Paranal, another ambitious project is taking shape. The extremely large telescope, currently under construction, will be equipped with at least 6 lasers to ensure it delivers the sharpest possible images for a ground-based observatory. What makes this technology truly revolutionary is how it transforms the capabilities of Earth-based astronomy. Space telescopes like Hubble and James Webb provide incredible clarity, but are extraordinarily expensive to build, launch, and operate. With laser adaptive optics, ground-based telescopes can now approach that level of precision while remaining accessible for regular upgrades and maintenance. This brilliant solution, literally creating stars with lasers to see the real ones better, represents one of the most innovative approaches in modern astronomy. It's allowing us to peer deeper into the cosmos than ever before, all while keeping our feet firmly on the ground. And while on the subject of telescopes, let's get an update from the JWST. The James Webb Space Telescope has made another groundbreaking discovery, this time finding the first confirmed planet orbiting a dead star. This isn't just any exoplanet. It's also the coldest one ever directly observed, offering astronomers unprecedented insights into planetary evolution. The planet, named WD 1856 plus 534b, was actually first spotted back in 2020. But scientists weren't entirely sure whether it was truly a planet or possibly a brown dwarf, one of those failed stars that never quite gathered enough mass to ignite fusion in their cores. It took the incredible sensitivity of the James Webb Space Telescope to settle the debate. Located about 80 light-years from Earth, this Jupiter-sized world orbits a white dwarf, the dense, Earth-sized remnant core left behind after a sun-like star has exhausted its nuclear fuel, expanded into a red giant, and then collapsed. What makes this discovery particularly fascinating is that the planet completes an orbit around its dead star every 1.4 days, placing it remarkably close to the stellar remnant. This proximity creates what astronomers call a paradox. WD 1856 plus 534b exists in what should be a forbidden zone, a region so close to the white dwarf that any planet there should have been completely destroyed when the star expanded during its red giant phase. Yet somehow, this massive world survived, or more likely, migrated inward after the star's violent death throes had subsided. As Marianne Limbach, the astronomer who led the study at the University of Michigan, put it, "This is compelling evidence that planets can not only survive the violent death of their star, but also move into orbits where we didn't previously necessarily expect them to exist." The planet is extraordinarily cold, with a temperature of about negative 125 degrees Fahrenheit, negative 87 degrees Celsius. This makes it significantly colder than the previous record holder, Epsilon Indi AB, which is a relatively balmy 35 degrees Fahrenheit. The extreme cold, combined with its orbit around a white dwarf, offers astronomers a unique laboratory for studying planetary atmospheres and evolution. This discovery has wide-ranging implications for our understanding of cosmic evolution. It suggests that the migration of planets after stellar death might be a key mechanism for positioning worlds in the potentially habitable zones around white dwarfs, regions where liquid water and potentially life could exist. While this particular gas giant wouldn't be habitable, the principle applies to smaller, rocky worlds as well. The James Webb Space Telescope hasn't yet reached its theoretical limits for detecting cold objects. Future observation programs aim to push those boundaries, potentially allowing astronomers to detect planets as cold as negative 324 degrees Fahrenheit. Such capabilities would accelerate our understanding of exoplanets similar to our own Jupiter and Saturn, placing our solar system in a broader galactic context. The research team isn't finished with this fascinating system either. They plan to conduct a second JWST observation this July, hoping to spot any additional planets that might be gravitationally bound to the star. Finding another planet could help explain how WD 1856 plus 534b managed to migrate to its current close orbit around the white dwarf without being destroyed in the process. Whether or not they find additional planets, these observations represent a crucial step forward in understanding how planetary systems evolve through the dramatic final stages of a star's life cycle, knowledge that may one day help us predict the ultimate fate of our own solar system. Okay, it's time to get outside and look up. Get ready for a spectacular celestial light show as the Eta Aquarid meteor shower is set to peak on the morning of Tuesday, May 6. That's this coming Tuesday. This dazzling display occurs when Earth passes through the debris trail left behind by perhaps the most famous cosmic wanderer of all, Halley's Comet. During the peak nights of May 5 and 6, well-positioned observers could witness up to 50 meteors per hour streaking across the night sky. These shooting stars are actually tiny particles of primordial comet dust, some no bigger than grains of sand, that slam into Earth's atmosphere at the astonishing speed of 40 miles per second. That's about 144,000 miles per hour. The shower takes its name from its radiant point, which appears to be near the star Eta Aquarii in the constellation Aquarius. This makes the southern hemisphere the prime viewing location for this particular meteor shower, as Aquarius rises much higher in their night sky this time of year, allowing observers there to catch the greatest number of meteors. For those of us in the northern hemisphere, don't despair. We can still enjoy the show, though with somewhat reduced numbers. The best viewing time will be during the pre-dawn hours, when Aquarius rises in the eastern sky. Observers in places like New York might expect to see around 10 meteors per hour. While fewer than our southern neighbors, it's still a respectable showing for a meteor shower. What makes the Eta Aquarids particularly special is the nature of the meteors themselves. They're known for leaving glowing debris trails that can persist in the night sky for several seconds after the meteor itself has disappeared. These luminous trails are sometimes called persistent trains and add an ethereal quality to the shower. For the best viewing experience, experts recommend finding a spot 40 degrees away from the radiant in the direction of your zenith. That's the point directly overhead. Allow at least 30 minutes for your eyes to fully adapt to the darkness. And remember, binoculars or telescopes aren't necessary or even recommended for meteor watching. Your naked eyes, with their wide field of view, are the perfect instruments for taking in these fleeting celestial visitors. While the shower peaks on May 5-6, the Eta Aquarids have actually been active since April 20, so keep watching the skies in the coming days as activity ramps up. There's always the chance of catching an especially dramatic fireball, a meteor that burns exceptionally bright as a larger chunk of cometary debris meets its fiery end in our atmosphere. This celestial light show is just one of 2 annual meteor showers produced by Halley's Comet. We'll cross its debris field again in October, creating the Orionid meteor shower. So even though Halley itself won't return to the inner solar system until 2061, we get to enjoy its cosmic calling cards twice each year. Finally today, an update to a story we covered yesterday. There's new information. After more than half a century silently orbiting Earth, a relic of the space race is finally coming home. The Soviet Union's Cosmos 482, a failed Venus probe launched back in 1972, is expected to re-enter Earth's atmosphere around May 10, give or take about 2 days, according to satellite tracker Marco Langbroek. This isn't your typical space debris. Cosmos 482 was meant to be a sister mission to the successful Venera 8, which successfully landed on Venus and transmitted data for 50 minutes before succumbing to the planet's crushing atmosphere and scorching temperatures. Unfortunately, Cosmos 482's upper stage rocket malfunctioned after reaching Earth orbit, stranding the Venus-bound spacecraft in our planet's gravitational embrace. What makes this re-entry particularly fascinating is that the surviving component appears to be the actual lander module. a reinforced capsule specifically designed to withstand the extreme conditions of Venus. This robust engineering means it might actually survive the plunge through Earth's atmosphere intact and reach the surface without disintegrating. Recent images captured by satellite tracker Ralph Vandenberg in the Netherlands reveal intriguing details about the wayward spacecraft. His high-resolution photography shows what appears to be a clear, compact ball, presumably the lander itself. Even more interesting, several frames seem to show a weak, elongated structure extending from one side of the spherical object. This has led to speculation that the lander's parachute may have prematurely deployed during its decades in orbit. Vandenberg notes that the object might be tumbling, which would explain why this potential parachute is only visible in certain frames. If confirmed, this would be an extraordinary development, a spacecraft that not only survived 53 years in space, but actually initiated part of its landing sequence while still in orbit. The re-entry is expected to be a long, shallow trajectory through the atmosphere due to the spacecraft's current orbit. This, combined with the age and condition of the object, introduces numerous uncertainties about exactly when and where it might return to Earth. However, the fact that this capsule was engineered to withstand Venus's atmosphere, which is far denser and hotter than Earth's, gives it a fighting chance to reach the surface relatively intact. This unexpected return of Cosmos 482 offers a rare opportunity to examine early Soviet planetary exploration technology that has endured more than 5 decades in the harsh environment of space. For scientists and space enthusiasts alike, this visitor from the early days of interplanetary exploration provides a tangible connection to the ambitious dreams of the first space age. Well, that brings us to the end of today's cosmic journey, and what an extraordinary collection of discoveries we've explored together. From the hidden population of mini-moons that may be scattered throughout our orbital neighborhood to giant telescopes shooting lasers into space, the universe continues to surprise and captivate us. The James Webb Space Telescope's discovery of a planet orbiting a dead star challenges our understanding of planetary survival, while the upcoming Eta Aquarid meteor shower promises to paint our skies with celestial fireworks. And the imminent return of a Soviet Venus lander after 53 years in orbit reminds us of humanity's long history of reaching toward other worlds. If you've enjoyed today's episode, I'd love for you to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and catch up on all the latest space and astronomy news with our constantly updating newsfeed. You can subscribe to Astronomy Daily on all podcast apps, including Apple Podcasts, Spotify, YouTube, and iHeartRadio, or wherever you get your podcasts from. I'm Anna, and I'll be back soon with more fascinating stories from the cosmos. Until then, keep looking up. There's a lot going on if only you look.